Anywhere you go, give it on. Anywhere you said, anywhere.
Hi guys, this is Jake with Think Free Live Free, and today I'm busy with running my AC outlets, my AC wire for my refrigerator and for my kitchen appliances, also for where I'm going to mount the TV. So I got this wire. This is an extension cord, a 100-foot extension cord. It's a 12x3. It's stranded pure copper wire, as you can see there. I'm using that to run my AC circuits. I'm going to do a 20 amp in the kitchen here, and then another 15 amp here. I do just have a regular refrigerator. I didn't want to spend $600 on a fridge. I think I spent about 200 bucks. So I ran that through the housing there, and then that's going to come out over here. This is where my breaker box will go for my AC outlets, also for my DC. So the one is for the refrigerator and the other one is for the kitchen appliances up here. I'm going to put a TV right there. So I'm going to run that through the cavity on the side there and down to the breaker box over there. That's what I'm doing today. It's like 95 degrees outside, so it's pretty hot, but at least I'm inside and it's shaded. I don't mind the heat. So my refrigerator is going to go right here, and then I'm going to pigtail another outlet up here for the kitchen. This is going to be a 20 amp outlet that's going to run to that one as well, and then this is going to be a dedicated 20 amp by itself for whatever kitchen appliance I'm going to use there. And then I ran the solar wire out to here because my inverter is probably going to go in this area somewhere. And then all my DC wiring for my fan, water pump, and for the puck lights is coming out here. My main breaker panel is going to go right there. And here's my breaker panel. It's got a DC side and then an AC side. Next thing is I'm going to take that panel off where the TV is going to go and install that AC wire running. I'm going to install an AC outlet there, and then it will run down to the breaker box. So I've had to take off some of my panels here so that I can cut out the electrical boxes for it. So this is the head of the bed. I'm going to put USB outlets right there, so it's easy for phone charging. I did not want to go lower with it because I did not want it to affect when you're watching TV and you're putting your head against the side. So, and I ran the cable all the way around from the other side through the roof there. And I had to take this off so that I could cut it. And I put it back on, so the electrical box is going to go in there now, and then I can start wiring up my outlets. So next thing, I got to do the same on this side. I got to measure where the box is going to go, and then cut that out, and then I'll put that up. Okay, so I've cut out the panel where the TV is going to go. It's going to have two electrical outlets on each side. The TV will be mounted here, so it will have an outlet for the TV right there. And then this is probably going to be some kind of kitchen higher outlet, maybe for a microwave or something. I'm not 100% sure yet. The next step is to cut this panel. So I need to cut the electrical outlet for that. So I have to line this up and then see exactly where I want that electrical outlet. And then on this side, my breaker box, I'm gonna put right there like that. So it is gonna go through this other panel somewhat, and then I will build supports there for it. So I did the cutout for the electrical box. There you can see it fits in pretty well. And then the cutout for the electrical outlet. It was 106 degrees today, so I waited till a little bit later in the day to start working on certain things. I'm getting ready to install my shore power 30 amp outlet. I'm going to mount that on the passenger side, so where the door slides out, more or less in this location here. My breaker panel is going to sit here, so I'm going to try to measure this and then do a pilot hole from this side, and then I'll go to the other side and finish it off. This is the 30 amp shore power inlet. I'll be using a 2 1/8 hole saw, and there's a lot of different sizes that I got like on Amazon and what people have been using, but I actually measured the back side of this side here to the other side is exactly 2 inches, so I figured that 2 1/8 will clear that just fine. Alright, so I got my pilot hole drilled right here. So I'm gonna use the 2 1/8 hole saw now to get that hole cut out. Alright, so we got our hole cut out. So I'm gonna go ahead and clean this really good and then file the edges a little bit, and I think I'm gonna apply some paint to that just to ensure that it doesn't rust. My inlet on there and drill 4 holes and then attach that. I'm test fitting the inlet and it's absolutely perfect. There's a little bit of extra room, but it is pretty damn close. So it's quite a nice tight fit. So I would suggest using a 2 1/8. They say to use a 2 3/4. I think your hole's gonna be too big. It's going to be really close to your screw. So I hope this helps anybody out there also doing this and wondering about the hole size. This is for the 30 amp. You can see here on the other side. I'm sorry about the light. I'm having to do this a little bit later. I painted the hole. So I got the back of the shoreline power inlet also attached. I ran my wires through here and then screwed this down so that it keeps the wires nice and tight so that you can't tug on them. And then I also went ahead and zip tied this housing so that it can't move. Otherwise it keeps it in there pretty tight, but this is just an added measure. This cord that I'm using, it's just a dryer washer dryer cord. It actually has 4 wires. I'm not using the red wire, so I just taped that off with electrical tape, so there's no current running through it or anything. But I had this wire laying around. It's stranded wire, so I'm using this for my shoreline inlet. It's 10-3, actually this is 10-4 stranded wire, so this is rated for 30 amps. So I think this will do just fine. As you can see there, I had to cut out my spray foam so that I can attach this plastic housing, the back of the wiring box, and I ran my cord down there, and then this end will go into my inverter charger. As you can see here, I got my box connected. It's just 4 screws. You pre-drill those, and then you screw the 4 screws in. I also applied butyl tape to the rim of the hole that the whole inlet goes into. I am installing GFCIs. Usually the first outlet of the circuit is going to be a GFCI. That way it will protect all the other outlets on that circuit. Here's a little picture of it. Basically states that if you place the GFCI in position A for your first outlet, it will protect outlet 2, outlet 3 that's on that same circuit. When you're doing your stuff, you can put regular outlets for outlet 2 and 3, but make sure to put a GFCI for your first outlet. That way you'll have extra protection. So I had already installed a regular outlet on here. However, I started thinking about it, and just for more safety measures and for any kind of fire and things like that, or if these terminals get hit by rain or something like that, I think it's just a lot safer to put a GFCI on your very first outlet of your circuit. That way it will also protect the second and third outlet on that same circuit. Keep in mind, if you have 3 circuits, for example, make sure that you put a GFCI on the first outlet of every single circuit. That's the only way it will protect the other outlets. So your breaker panel is right here. You start off with the line side. Just read it on the back of your outlet. And then your second outlet, so the wire from the first outlet will go to the load side, and then it runs across to your line side on your second outlet. And then to feed your third outlet, you'll go to the load and feed that to the line side there. Alright, so as you can see here, I have a line coming in from the breaker box, and then I have another line going out to the second outlet. And that's where it gets a little bit more tricky. And by code, you are not allowed to put two ground wires on a ground screw. So you have to tie your two grounds here with a pigtail. So there's a wire nut, and then the pigtail goes to the ground screw. So the first thing I'm going to do is I'm going to connect my ground. So I have those pigtailed onto this wire nut. So both grounds are coming into this wire nut. And then there's a short pigtail. I could have made this a lot longer to make it easier on myself, but that's what I'm working with. I'm just going to go with it. Make sure that when you put your loop on there, you're putting that in this direction, that direction, so that when you're tightening your screw, you're tightening it with, you're actually tightening the wire on there. So my ground wire's on there. Then this bottom, it's gonna go like that. This bottom is the line, so that's coming straight from the breaker. So my first line running from my breaker is going onto here, and then this is the load side, so my white from my load is going to go on there, and then on the other side the black's going to go there, and then the black's going to go on there for my line side that's coming from the breaker. So on the bottom you have your line line side. You got your white on the silver screw, your black on the brass screw, and then on the top you have your load, which goes to the second outlet. You have your black screw, sorry, your hot, and your white, your neutral, and then the ground screw. They are pigtail. There's one pigtail coming from the ground screw to the two lines coming into this box. So I got my GFCI in. So now on to the next one. So the next one is over here. That will be my second outlet. And that second outlet will now be protected by this one. That second outlet is hooked up on the load, on the load side, and then it runs through here and it comes out here. So this that was on the load side on the first outlet is now going to be on the line side for the second outlet, and then this one will go to the load side, and then that outlet runs all the way to that side. So I wanted to show you this connection here. This has two outlets and two USB ports. It only has a line side, so it has two screws on each side. I covered that up with electrical tape, but so you only have a line side. There's no load, so you don't have additional screws at the top. So the way I did this was to create a pigtail, 3 pigtails that went straight off the outlet, and then your 2 wires are stripped, and then all the whites, so you have 3 whites going together, and then 3 blacks going together, and 3 grounds going together with and then you attach it with wire nuts. That way it feeds it onto the next outlet there, and the circuit continues. So I just wanted to show you that in case you were wondering how you might want to do that. And on to the next one. I'm gonna wire a GFCI outlet and show you how I do that. So as you can see here, I have 3 wires and another 3, so 6 altogether. This one is running to this top outlet here, and this is going to be the first outlet from the breaker. The first outlet will go on the line side, and the second outlet will go on the load side. Keep in mind that your grounds, these 2 grounds, will have to be pigtailed together, and then you'll run a wire from these 2 to the ground screw, and then you'll attach these with a wire nut. However, the black and the white, they will have screw terminals on the outlet. Okay, so that's wired up. You can see this is the load side, the top is the load side, and that's going up to that outlet there. The white goes on the left, the black goes on the right on the brass screw, and then from your line side, the bottom is the line side, white goes on the left on the silver screw, black goes on the brass, and then you have to create a pigtail here for the ground screw. I have a white wire coming off the ground screw, but that, just assume that's a green wire. It's just a pigtail, and this pigtail will connect to these 2 grounds, and then you'll screw that down with a wire nut, and you'll be all set. Guys, thank you so much for watching this week. Please hit the like button, please subscribe, and please share with your friends. It really helps the channel grow. Alright guys, good luck on your van builds, and take care. Stay safe. Bye.